Hello. Okay, welcome to lesson 9. Okay, so last week we have learned introduction of function. Okay, and I've asked you to do question number 5, 6, and number 9. Okay, please check your answer and please tick it. Okay, tick by your own. The answer for number 5 is here. Okay, number 6 is here, and number 9. Okay, please check your answer and mark by yourself. And if you don't understand, you can always personal text me and I will answer your question. Alright? Okay, today we are going to the next subtopic, which is inverse function. Right? Okay. So inverse function, right? Okay, you can see here. Inverse function is a function that reverses another function. Okay, the word inverse here, or another word of it is undo. Okay, so it's a process of undo the function. Okay, I can illustrate using this picture here. Okay, look at this apple, right? It's an input. Okay, input. So when it goes through the function f machine, the apple become and turn into a lemon. Turn into lemon, and the lemon, when passed through the inverse function, you see that it turns back to apple. Okay, so this way it is a reverse way. Okay, the apple becomes lemon is a function, and then lemon turns back to the apple, so it's a reverse. It goes back to the original input. Okay, so it's a reverse process, and you need to know what is the rule of the function for inverse, right? Okay, I give you another clearer example. Okay, like last week when I mentioned about the machine, okay, the function machine, okay, which has input and output. All right, so if you put a number 2, object of 2, and if it generates a rule of times 2, and your output will be 4, right? 2 times 2 is 4. And if you put in 5, and your output will be 10, because 5 times 2 is 10, right? So inverse, it means that it's a reversing function. It's a reversing process now. So you are going to put in your output, which is your 4, and it will generate and gives you back 2. Okay, so it's like reversing. Look at the arrow here. So 4, you sub in, you put it in, and it will generate to become 2, and your function now is not times 2 anymore, right? So it becomes a reverse, so it becomes a dividing by 2. So 4, when you divide by 2, you will get to 2, and 10, it reverse back, you divide by 2, it will get to 5. So this is a reverse process. So function f, okay, to write it in a clearer, denoted as f of x is 2x for this machine, right? It generates 2x. The rule is 2x here, right? So it means that f of 2, your input is 2, it will give you a 4, right? And if you have a input of 5, it will give you a 10. Okay, inverse, for inverse function is denoted as f inverse f negative 1 of x, right? F inverse of x, okay, it's written as f inverse of x, right? F negative 1 bracket x. Okay, so it inverse, it means that you are no longer 2x. The rule is no longer 2 times x. Look at the machine here that I wrote just now in a pink. Okay, the rule, the general rule now is not times 2, but it's instead of times 2, it's a divided by 2. So your function, your inverse function, the rule for the inverse function will be x over 2, or x divided by 2, right? So it means that when you put in 4 over 2, or 4 divided by 2, it will become a 2, right? And so if you inverse f inverse of 10, it will right? It's an inverse process. Okay, look at this. Right? And then you look at this. It's a reverse process. Right? Okay, repeat that one more time. So if you have a f, your input is 2 and it will become a 4. Now if you inverse back a 4, you put in the 4, your output become an input now. So your output will become the 2. So it reverses back to the original input. Right? Okay. Please take note of this. Okay. So we can write f of 5 is 10. Therefore, f inverse of 10 will be equals to 5. Okay? It's a reversing process. It's a reverse. So we call it inverse function. Right? Okay. In this machine, this function machine, it's a simple rule, right? Times 2. It can be +1, +2, +3, and if it's inverse, then it become plus, become minus, minus become plus, right? But it can be as complicated as, for example, okay, again, I will use the machine. Okay, now let's say if this machine generates a function that is 2x plus 3, right? So if your input is 2, okay, so we can write this as f of 2 will be equals to 2 times 2 plus 3, and it will generate a output of 7. Your image will be 7, so your output here will be 7. Right? So the function f of x is 2x plus 3. But how are you going to find a rule or a function that's denoted as inverse, f inverse? So f inverse, what can you write it as? Okay, what is the expression of f inverse here? Okay, unlike this one, times 2 become divide 2, right? It's much easier. But when it comes to this, okay, it can be as complicated as for example, 2x plus 3 over x minus 2. Okay, this one, how are you going to write in a rule that is inverse function for it, right? So, okay, so from here, your first step is to let your y equals to 2x plus 3, right? You let y equals to 2x plus 3. Okay, y here is your input, is your output, and your x is always your input, right? So y equals to 2x plus 3, or you can write as 2x plus 3 equals to y, doesn't matter, it's still the same as long as your x is your input, y is your output. Your next step is to switch or interchange your x and y. Okay, your x will become your y will become your x. Why? Because now our input here will become our output, and your output will become your input. It's changing the way around again because it's a reverse. So you change your input to your output become your input, right? Okay, so your x and y, you change it, it will become y, 2y plus 3 equals to x. Right? And your next step is to make y as subject, right? To make y as subject. So 2y equals to x minus 3, and your y is equals to x minus 3 divided by 2 over 2. And this function here is your f inverse. Okay, so your f inverse now is equals to x minus 3 over 2. Okay, to prove that, okay, look at the machine again. This function machine. Now our inverse become x minus 3 over 2. So if you put in your output into your f inverse, 7 minus 3 over 2 will become 4 over 2, which is 2. Look at here. Your 2 going through function f, it will become 7. So now 7, to go back to this 2, you need another general rule. You need a rule which is denoted as what we found just now, x minus 3 over 2. So your F inverse now is x minus 3 over 2. Alright, okay, let's try this. You sub in 3, okay, into this function f. Okay, so it will become 2 times 3 plus 3. It will become 9. Your output is 9, right? And this 9, if you sub in into this inverse here, this inverse, okay, this inverse function which is x minus 3 over 2, which is 9 minus 3 over 2, which is 6 over 2 is equals to 3, and there your input here is 3. Okay, to write down in a proper way where you will understand more. Okay, this is arrow diagram. Your f function is 2x plus 3, whereby you sub in 2 into your x and it will generate and gives you an output which is 7. Okay, and to get the expression of the inverse here, which is denoted as f inverse of x, it will be equals to x minus 3 over 2. Okay, we'll go to the technique later on, but make sure that you understand what inverse means. Alright, so inverse function is a function that reverses another function, or the process of undoing it. Okay, the undoing it. So in this subtopic, we need to find out the expression when you are given a function f. Okay, you are given a function f and you need to find the inverse of it. Okay, the rule of the inverse, the expression of the inverse. Okay, right. Okay, so this is the example. Okay, please take note that, okay, in this case, if we have f of 2 is equals to 7, am I right? So f inverse of 7 will be equals to 2. Okay, your input here is 2, your output is 7, right? Input, output, and if you sub in your inverse, okay, it will go back to output, will become your output become input now, right? All right, okay, so now we go to try it for, okay, to make you understand more. Okay, function is defined by f dot dot x, arrow 3 minus 4x. Okay, it can be written as f bracket x or f of x equals to 3 minus 4x. Okay, don't worry, you can always change to this form. Okay, A, express f inverse. Okay, you need to write down the inverse, the expression for the inverse. You have the expression for f, which is 3 minus 4x. Okay, just like I say, you have x as your input. Okay, your output will let it be y, right? Your output will be y. So the process of f here, the f function, you'll get an output of y. So now you need to find what is the expression for inverse. Okay, what is the expression for inverse? Okay, your fx is already given 3 minus 4x, so now you have to find out the expression of f inverse. How do you find that? Okay, again, step 1, you let y as your fx. Okay, since your fx is equals to 3 minus 4x, so your y is equals to 3 minus 4x. Okay, it's sometimes maybe easier for you to write as y, okay, because you already get used to y. Is that okay? So your y is your output, right? Your x is your input. Okay, you remember that. Okay, so your next step, your x and y, you interchange or you switch them. Okay, so your y will become x and your x will become y. Okay, you switch. Okay, you interchange. Okay, interchanging. This step is called interchanging x and y, or switching x and y. Okay, the reason is because now your input is your x, your output is your y. You are interchanging it. Now you are looking for your x and y, which is your x now will become your output and your y is your input. Okay, you are looking for the expression when x and y reverse, right? So you interchange your x and y. Okay, and then now you make y as subject. Your next step is make y as subject. Okay, you make y as subject. So negative 4y become positive 4y and 3 minus x. Okay, this negative 4y become plus 4y, x move become minus x. Then y will equal to 3 minus x over 4. Okay, so now your inverse function will become 3 minus x over 4. Okay, you can write as f inverse without the bracket x also can, or if you want to write like this, also okay. Okay, so you have found your expression for your inverse. Alright, okay, so now part B, this is part A. Part B, I'll write it here. Okay. Hence, evaluate f inverse of 1. F inverse of 1. B part 1, yeah? Okay, so now, you already have your f inverse here, which is 3 minus x over 4, right? Okay, so your f inverse, your x is 1 now. Okay, maybe I should write down like this. F inverse is already found it just now, which is 3 minus x over 4. This is the expression. And then if you sub in your 1 into your x now, okay, so 3 minus 1 over 4, which is 2 over 4 and is equals to 1 over 2. Okay, so this is your answer. For part 2, how about f inverse of negative 5? So same thing, since you already found the expression 3 minus x over 4, you can sub in your x, negative 5 over 4. So it's 3 plus 5 over 4, which is 8 over 4 and equals to 2. Right? Okay. So what can you understand from this try it for? Okay, I explain to you again. Right? Okay, you have x as your input and your y as your output. Okay, this is the arrow diagram. Okay, so let's say you sub in the 1 over 2 into the function of 3 minus 4x, which is in this question, try it for 3 minus 4x, 1 over 2, and you get, after you sub into the x, okay, when you sub in half, it will become a 3 minus 4 times half, which will give you a 1. Okay, and then your output here is 1. Okay, and if you sub in 2, okay, if you sub in 2, 3 minus 4 times 2, it will give you a negative 5, which means your output is 5. Okay, so our function here is already given fx is 3 minus 4x, and what we do just now is the reverse process, is finding the f inverse, and using the steps that I taught you just now, the function inverse is 3 minus x over 4, right? 3 minus x over 4. So please take note that when we sub in the output now 5, let's say we sub in this 5, sub in the 5, 3 minus 5 over 4, It's supposed to be -5. I'm sorry. It's supposed to be -5. Yeah, I wrote wrong just now. Okay, it's a -5 here, you see. Okay, if we sub in -5, okay, this will become a +5. Okay, I write a proper one. 3 minus -5/4. It become 8/4, which is 2. You see, your output just now will become your input again, which is 2. Okay, which means that your function inverse function here, the rule here, the expression here is correct. Okay, you can try to sub in 1 again into the f inverse. When you sub in 1, you'll get back half. Okay, you see, your output will become your input, right? So inverse function is a reversing process. Okay, it's a reversing expression. You need to find the reverse expression. Okay, it's the reverse. The word inverse, you can relate it as reverse or undo. Okay, that is for trait 4. Now we go to trait 5. Okay, a function h. Okay, your function is not necessarily have to be f. I mean f. Okay, it's not necessarily have to be f. It can be h, g, or any other alphabet, right? Okay, so your h now, the function of h is x/x minus 4. A. State the value of x for which h is not defined. Okay, not defined. Sometimes the question can ask about undefined. It's the same meaning as not defined, right? Okay, when h is not defined, it means that your denominator, okay, your h of x is x/x minus 4. Your denominator is x minus 4, right? So your denominator cannot be 0. Okay, what happens if your denominator is 0? What happens if your denominator is 0? Okay, if your denominator is 0, it means that x/0. X divided 0 is undefined. It's not equal to 0, right? Okay, x/0 is undefined. When you press calculator, it's math error. You can try that using 2 divided by 0 or 100 divided by 0 is undefined. You cannot divide by nothing. Okay, you cannot divide by nothing. Okay, it only becomes 0 when 0 divided by a number. For example, 0 divided by 2, yes, it is equals to 0, right? So if your denominator is 0, okay, it will be undefined. Okay, it will give you a math error if you're using calculator. Okay, so what is the value of x for which h is not defined? So we can say that this x minus 4, if it's equals to 0, it means that it's not defined or it's undefined. Okay, so x minus 4 equals to 0, so your x is 4. So if your x is 4, you go back to this denominator again. If your x here is 4, so it means that 4 over 4 minus 4, which is 4 divided by 0, so it's undefined. It's obviously undefined because 4 cannot be divided by 0, right? So state the value of x for which h is not defined. So x equals to 4. Okay, we can write like this. H is not defined when x is 0. X is 4. Okay, h is not defined when x equals to 4. Okay, I write too big here. Okay, part B. First part. Express h inverse. Okay, h inverse. Okay, so first step. Okay, you let hx equals to y. So your y equals to, oops, this one. Okay, your y equals to x over x minus 4. Okay, you let h equals to your y. Okay, your step 2 is interchanging x and y. Okay, you change the x and the y, so your y become x. and your x become y. Okay, interchanging x and y because your input become your output become your your input become output become input. Is a reverse. You're finding the inverse, right? So next step is you find y as subject. Okay, you make y as subject. So how do you make y as subject? You move this y minus 4 to the other side, become times. So it's a bracket. So xy minus 4x equals to y. Okay, how are you going to make y as subject when you have y on the left side, y on the right side? Okay, you see you have y here, you have another y here. What you do is you move the y together. Okay, so xy, y on the right side move to the left side become minus y, and negative 4x become plus 4x. Okay, you move the y together at one side. Okay, once you gather the y on one side, at one side already now, right? So you factorize y, you take out the y, and it will become x minus 1. Okay, equals to 4x. Okay, I'll continue here. So now you can move this x minus 1 to the other side, become divide because the bracket means times, right? So y will be equals to 4x all over x minus 1. Okay, so now your inverse is 4x over x minus 1. Change the y into f inverse. Okay, this is your expression for your f inverse. Done. Okay. Part 2. State the value of x for which h inverse is not defined. Okay, now h inverse. We look back at our h inverse. Oh, okay. Just now I wrote f here. I shouldn't have written f. It should be a h. Okay, please change that. This one's supposed to be h inverse. Okay, it's supposed to be h inverse. Follow the alphabet that is given. Right? If it's h, then h is. If it's f, then it's f. Right? So when h inverse is not defined, okay, which is your denominator cannot be 0, right? So your denominator for your h inverse is x minus 1. You see that? X minus 1. So your x minus 1, if it's equals to 0, if it is equals to 0, again, if it is equals to 0, it means that the whole expression of your h inverse is undefined or it's not defined. Okay, so your x is 1. Okay, meaning to say that your h inverse is not defined when x equals to 1. Okay, your h inverse is not defined when x equals to 1. Right? See again. You sub in 1 into your expression. What will happen? 1 minus 1 here will become 0. And any number divided by 0, it will be undefined. Okay. Now part C. Evaluate h inverse of 3. Okay. You already have your expression of h inverse. Okay. Your h inverse is, okay, you see this, 4x over x minus 3. Okay, so you just need to sub into the x. 4 bracket 3 over 3 minus 1. So it's 12 over 2, which is 6. That is the answer. Okay, extra information here. Okay, if you have an inverse of h, okay, h inverse of 3, it gives you a 6 from part C, right? So it means that if your h function, your input is 6, your output will be 3. Okay, this is extra information here. Okay, we continue to try it 6. Okay, try it 6 is at page 80. Just now try it 5, it's page 79. Try it 4 and try it 5 is in page 79. Now we go to try it 6, right? Okay. A function g, okay, is given as g of x equals to 7 minus 2x. Without finding g inverse, okay, now without finding the expression of g inverse, okay, evaluate g inverse 9. Okay. The extra information that I gave you just now, okay, is useful here. Okay, you have to think in this way. If we have g x and if it gives you a y, your output is y. Okay, your g inverse of y now will become x. Okay, its input become output, your output will become input. Alright, so xy here terbalik. Okay, exchange. So in this case, if we are not finding any expression, how are we going to find that 9 for the 9 if we put in 9? Okay, so again, if we have our 7 minus 2x, okay, again, in the arrow diagram, if you understand the arrow diagram, x, your gx is 7 minus 2x. Okay, then you get a y. Okay, so if you sub in the value of any number, you don't know the number, and it will give you a 9. Okay, from part A. Okay, I'm talking about part A. So now if we inverse the 9, we inverse and your input is 9, what is the value here? Okay, your g inverse, and without finding any expression, how are you going to find back the input, the original x? Okay, and we know that this is our output, right? So it means that 7 minus 2x is equals to 9. Okay, so it means that 7 minus 2x equals to 9. Okay, now you are looking back how to find the original, how to find the input if your output is 9, right? So from here, 7 minus 2x is equals to 9. You find your x. Okay, negative 2x will be 9 minus 7, which is 2. And your x is 2 divided by negative 2, which is negative 1. Okay, so your inverse of 9, g inverse of 9 is equals to negative 1. So here will be negative 1. Okay, meaning to say that if you sub in negative 1, it gives you a 9. And inverse back, if you sub in the 9, it will give you a negative 1. Okay, without even sub in into the expression, without even finding back the expression. Okay, you can do in this way. Right? That is for part A. Part B, g inverse of negative 3. So same thing, if you have a 7 minus 2x and your output is negative 3, you find back what is the x, find back what is the input, right? Negative 2x equals to negative 3 minus 7. So negative 2x will equals to negative 10, and your x is negative 10 divided by negative 2, and your x is equals to 5. Okay, so your g inverse of negative 3 is equals to 5. This is the answer. Okay, so it means that your output is negative 3. What is your input? Okay, so finding back the x, so it's a 5. Right? Okay, you can double check the answer. So your inverse, your g function is 7 minus 2x. So if you sub in your 5, 7 minus 2 times 5, 7 minus 10, and it's a negative 3. See that? So meaning to say that an invertible function f, it means that it can be reversed back. Okay, it can reverse back the function. Is given as f dot dot x arrow mx plus c. So it means that your to mx plus c. Okay, you have 3 unknowns here now, right? Where m and c are constants, okay? It is known that f inverse 5 equals to 3, okay? F inverse of 5 is equals to 3. So, if f inverse of 5 is 3, it means that f of 3 is equals to 5. Okay? And your f inverse of 1 is negative 1. So, it means that f of negative 1 will be equal to 1. Okay? Okay, it's coming from the question here. Okay, you need to know how to convert to this. A. Find the value of n and of c. Okay, so you have two, you can form a two equation here. The first equation, since your f of x is equals to mx plus c, so you can sub in 3 into the x, mx, your x is 3, plus c equals to 5. Okay, because you are given f of x equals to mx plus c, so you just sub in the x, which is 3, into the x here, 3. So 3m plus c is equals to 5. This is your first equation. Right? And your second equation, same thing, you sub your negative 1 into the x, equals to 1. So negative m plus c equals to 5, and this is your second equation. So now we solve these two equations using simultaneous equation. Okay, I will use the elimination method. Okay, I will put together first 3m plus c equals to 5 as your first equation. Second equation is negative m plus c equals to, did I write wrong just now? Oh, yeah, this 5 is supposed to be 1. Sorry. Okay, equals to 1. Okay, so first equation, second equation. Okay, I will minus them because the c, I want to eliminate the c. So 1 minus 2, the first equation, minus the second equation. So 3m minus negative m equals to 5 minus 1. Okay, we see in a vertical way. 3m minus negative m and then 5 minus 1. So 3m plus m is 4m and 5 minus 1 is 4, and therefore our m is 4 divided by 4 is equals to 1. And how about C? You sub in, sub into, let's say 2. Okay, so negative m plus c equals to 1, which is negative, your m is 1 plus c equals to 1. So c equals to 1 plus 1, which is 2. Ta-da! Alright, part B. Hence, evaluate f inverse. Okay, now we have to find out what is the function f first, because since we already found our m and c, we sub it back. So f of x is equals to, your m is 1, x plus c is 2, which is x plus 2. Basically, you don't need to write the 1 in front of the x. Okay, so your f of x is x plus 2, right? So we have to find f inverse of 8. F inverse of 8, okay? So which means that your x plus 2 is equals to 8. Okay, like the one I mentioned before. Okay, so if you have f of x is equals to y, input output, so your f inverse of y will equals to x. Okay, so it means that now your inverse of 8 is your output, and you need to find what is the input. Okay, you need to find back what is the input. Okay, okay, so this is your output 8. You find back what is the input. Okay, so your x equals to 8 minus 2, which is 6. Done. Okay, maybe I can explain this part again. Okay, you have x. Okay, go through the function of fx, which is equals to x plus 2. It gives you a y, okay, which is your x 6. Okay, you found just now is 6. It gives you a 8. Okay, so it means that just now before even you found the y, the 6, okay, you don't know what is the value of this. They're asking you to find f inverse of 8. Means that they're asking you to find what is the value of x if it's given your 8 as an output. Okay, so we found just now which is 6 without even finding the expression for f inverse. You did not even find that. Okay, you can use this method to find. Okay, so we have finished our try it 4, 5, 6, 7. I've covered inverse functions already. Okay, you can always rewatch. Okay, rewatch again from the beginning to understand more. And if you have any questions or any doubt, you can text me or ask me. I can explain to you again. Okay, whichever part that you need more explanation. Okay, so for now, after you have finished all this try it, you copy all this into your notebook. And yeah, some of you may ask, how am I going to copy these inverse functions, these notes here? Okay, you copy according to your own understanding. Okay, whichever that I wrote down here, that you copy it down, whichever that you look back into the notes that you are about to write it down. When you look back at it, you will understand. Okay, it's not necessary for you, of course you don't need to draw this apple and lemon thing, right? So you just write down for your own reference. Okay, for your own reference, you write in your own way. Okay, for your own reference. Okay, and try it 4 to try it 7. Yes, you copy to the question and the solution as well. Okay, and I would like you to do question in page 81. Okay, page 81, question number 1, 2, and 3. Okay, page 81, question number 1, 2, and 3. Okay. Okay, your task now is doing page 81, question number 1, 2, and 3. Okay, this is exercise 3.2. Okay, so that's all from me today. Thank you. See you. Guys, selamat berpuasa. Guys, okay, stay at home, stay safe. We'll meet each other very soon. Bye.